Okay, good afternoon. Welcome back to Pre-Calculus. So here we're going to be working on problem number 3 again. I didn't realize I didn't number these properly, but here we go. We're going to graph the function y equals negative 2 secant 4/3 x. Okay, we'll just have a go at how this is going to look. So here we go. We have y is equal to negative 2 secant 4/3 x. Now, first thing I know about secant is it's 1 over cosine. So I'd really like to graph cosine first before I have to go off and graph secant. The other thing that I want to do is like these, they're only like 4 points or 5 points I really would like to graph for cosine. And that's my, like, as I go for cosine, that's going to be 0, 2 pi, pi, pi over 2, and of course 3 pi over 2. Okay. So for cosine, here we go. For cosine, I'd really just like to graph these 5 points. This obviously keeps going forever and ever and ever. But if I can help it, those are the 5 points I would like to graph for cosine. This would be y equals cosine. So what I'm going to do is I'm going to figure out what does x have to be so that they would actually be equal to these points right here. So we can say, okay, I would like 4/3 x to be 0. What does x have to be so that 4/3 of x is equal to 0? So we're going to multiply both sides. We're going to say that we have 3/4 times 4/3. X is equal to 0 times, and we're going to say 3/4. This goes off to say x is equal to 0 times 3/4 is, of course, 0. So one of the points is going to be 0. We're going to have 4/3 x equals pi over 2. So we're going to go ahead and solve this for pi over 2. So again, we multiply both sides by 3/4, and we end up with x equals 3 pi over 8. All right. And then the next one is say 4/3 x is equal to pi, because that's the next value I'd like to get. So we're going to say x must be 3/4 pi. You just multiply both sides by 3/4, and that cancels out your 4/3. Now we have x is equal to 3/4 pi. All right. Next one, we're going to say we have 4/3 x is equal to 3 pi over 2. And again, we multiply by 3/4 on both sides, multiply 3/4 on both sides, and we end up with x equals 9 pi over 8. Right? And then lastly, we want 4/3 x to be equaling to 2 pi. What does x have to be so this whole argument is actually equal to 2 pi? So we're going to go ahead and say we want 3/4 on both sides, 3/4 on both sides. So x is equal to 2 times 3 is 6 pi over 8. Now, humans, I know because I happen to be one, despite what people will say, uh, really do like patterns. We are really good at patterns. And one of the things you can do with this method is you can start looking for patterns. So I have 3/8, 3/4, 9/8, 6/8. Okay. It seems like, I'm sorry, 6/4. Should make a 4 here. Okay. So people really like patterns. So one of the things I'm going to do is see if I can't turn everything here into eighths and see if there's some kind of a pattern going on here. To do that, I'm going to multiply the second term by 1, 2 over 2. I'm going to multiply this last term by 1, 2 over 2. So we're going to get x is equal to 0 pi over 8. That's a fancy way to write 0. X is equal to 3 pi over 8. X is equal to 3 times 2 is 6 pi over 8. And then we have x is equal to 9 pi over 8. And then finally, x is equal to 6 times 2 is 12 pi over 8. So one of the things I'm doing to check my work is saying, does this make a pattern for me? We have 0, 3, 6, 9, 12. Yeah, even if I only wanted to, if I wanted to keep going, I could write dot, dot, dot. And I think most of us would figure out, like, oh, I see the pattern. The next one's going to be 15, then 18, then 21, etc., over 8. So that's what we're going to do. So now that I have my points here, all right, we're going to go from 0 to, what's my last point here, is going to be 12 pi over 8. My middle term here is going to be 6 pi over 8, 6 pi over 8. My middle term over here is going to be 3 pi over 8. And then my last term here, 9 pi over 8. So I want to do a cosine. First thing I'm going to check is what is our magnitude is it's 2. Okay, or amplitude rather is 2. So we can go up 1, 2, we can go up 1, 2. So I've got to write a cosine that is upside down because there's a negative sign in front of it. So we're going to start here, here, all the way up here, back down to here, and then over here again. So I'm just going to kind of dot in my cosine to see what goes on here. And then I'm going to draw in my asymptotes because everywhere that the cosine crosses 0, we're actually going to have an asymptote when we go to draw this thing in for our secant. Pretend these are straight. Okay. Now let's see. What color should I make my actual thing here? Let's go with green. So my secant's going to be in green. So we're going to have our secant value looking something like this. Okay. So one thing I want to make sure is like don't think that that this is actually a disjointed graph. There's like a horseshoe looking thing here. There's a horseshoe looking thing over here. We could just contribute. We could just continue going on. This would be negative 3 pi over 8. This would be 18 pi over 8, et cetera, et cetera, et cetera. But the graph only has us graph one cycle, so that's all you have to go deal with. Let me look back at the original problem. Let's see here if we can go back and look at that. So we have to graph asymptotes, relative minimum, relative maximum. Uh, so we go ahead and do that. The relative maximum is this point. It's the biggest value relative to all the other points of what they'll call the neighborhood. Okay, so whatever I do with the neighborhood until I get to the asymptote, this is the tallest point. Same thing goes with this middle section. Uh, this is the relative minimum. It is the smallest point, the least valued point in this neighborhood of points that are around it. Okay, so that's a relative minimum compared. It's not the absolute minimum. The absolute minimum is going to be down here somewhere because there's bigger numbers, but the relative minimum is relative to the points around it. That's what we're going to be looking at. For those of you going off to calculus, those are words you're going to hear quite frequently. So, something to get used to. So with that, I'm going to stop. I'm going to say thank you very much for watching the video. Good luck with graphing, happy graphing, and we will see you in the next video. Thanks.